Let's see the first exercise. It says, a 90-kilogram skier glides at a constant speed over a horizontal surface of wet snow. Find the frictional forces on the skier. Okay? So, what we have right here is an object of interest, that is the skier. Okay? Because we are describing what the skier is doing and we are giving information about him. We know that the skier is 90 kilograms. Okay? So that is the mass of him. So what I do in the first place, this is what I call the step 0. In my step 0, I work on the sketch and also free body diagram and also the givens, okay? Everything that I need before applying the formulas goes on the sketch or in the zeros part, okay? So I have this guy, okay? And he is skiing, okay? He's skiing, so he has his own skies, and of course, he will look happy or scary. It depends, okay? But what does it say about? It says that his mass is equal to 90 kilograms. And it also says that it glides at a constant speed. That means that it's moving, okay, over a horizontal surface of wet snow. So let's call this is the horizontal surface and it's made of wet snow. Okay. Now think about these guys. What material do you think these guys are made of?
Of wood?
Wood, exactly. So in the table, okay, in the table, we're going to look for this situation, wood and wet snow. So let's look for this situation. Okay, we have steel on steel, ne. Aluminum steel, tampoco. Okay, so we're looking for wood on wet snow. Okay, so if you take a look to the second part of the table, the first one says wax wood on wet snow. Okay, so and here we have on dry snow, and there's nothing more about it. And then we have ice on ice, but no, okay? It's just not the same situation. The only one that fits perfectly is this one, the first one, okay? So we're gonna focus on the first situation. So for the first one, I know my static coefficient and my kinetic coefficient. So I'm going to include them both on the step 0, okay? Static friction 0.14 and kinetic friction 0.1. Okay, so I'm going to write the data right here, and I will say my static friction is coefficient is 0.14 and my kinetic friction coefficient is 0.1. Okay, 0.1. Now with this I have everything I need. So right now I will just include the free body diagram with all the forces. I will replace my skier by a dot, okay? Because the skier glides over a surface of wet snow. It doesn't matter the kind of surface, it just matters that it's on a surface. So I will have my normal force up like this. And down, I will always have my weight, okay? because my scatter is gliding at that velocity, I will know that my friction comes opposite to his motion, so the friction will go in this direction. With this, we do the free body diagram of all the situation over there. Okay? And the friction could either be static or kinetic. Okay? Now, now that we have everything we need, we're going to focus on the formula. The formula says that for either kinetic or static friction, I need to know the normal. So that will be my first step, to find the normal force. Now, take a look to the free body diagram. According to the free body diagram, my normal force is equal to my weight. The only difference is that the normal is going up, but my weight is going down. Since there are no other vertical forces, we can say that the normal is equal to the weight. So in the first step, what we do is we need to calculate the weight of the object. Calculate the weight. And the weight has this formula. Weight is equal to mass times gravity. Weight is also known as force due gravity. Remember this, okay? All we do after is substituting by the givens. So we say weight is equal to the mass, which is 90 kilograms, multiplied times the gravity, that is 9.81 meters over second to the second power, or you can even write it negative. It is not necessary that you write the negative, since already in your diagram here, you indicate that the weight is going down. But even though if you want to write it, it's not going to be wrong, but it's not necessary. Okay? So tell me what you get with this multiplication. How much do you get from that?
$882.9.
Okay, 882.9. And take a look to the units. We have kilograms and we have meters per second square. According to the information that I gave you the other day, also with the video, 1 Newton is the unit that we use to represent forces, and the weight is a kind of force. So the weight is measured also in newtons, because Newton is a compound unit that is made of kilogram and meters per second square. So every time you see those two units, those units together, that represent Newton. So you say, actually the weight is equal to 882.9 Newton. Okay, and this will be your answer for the weight, but that's not it. You can indicate that it's going down, or you can just write the symbol. Okay. Now you know, if you know the weight, you already know the normal for this kind of exercise. So you know that is 882.9 newtons. This one is going up, and the weight that is going down. Now, afterwards, what is happening is that you need to get the friction. Okay? So to calculate the friction, what we do is we apply the formulas. So we say static friction equals to static coefficient times the normal, And you also have the formula for kinetic friction, that is equal to kinetic coefficient times the normal. All we do is we're going to substitute by the values that we obtained, okay? So the static friction is going to be static coefficient, that is 0.14. Remember, I got this 0.14 from the table. The situation is wood on wet snow. So we go here, and this is where we get the coefficients, okay? Wood on wet snow. 0.14 for static and 0.1 for kinetic, okay? And we multiply this times the normal force, that is 882.9 Newton. So friction is a kind of force that is also going to be measured in Newton. Take a look, it is the only unit involved in the formula, so the final answer will be newtons. How much is this?
123.60.
Point?
60.
1 rounded. 606 is, this 6 gives 1 to the 0, and the 0 turns into 1, okay? So rounded is going to be 123.61. And that will be it for the static friction. And for the kinetic friction, we substitute by the givens. How much is this? It should be 88.29. Did you get the same?
Yes, miss.
Okay. With this, we finish the exercise. Now, let's take a look to the second problem I have here. It says a person moves a 180 kilogram sculpture made of metal over a horizontal metal platform. Find the frictional forces on the sculpture. So, in my step 0, I sketch the situation, okay? I will sketch the situation, and I have this person here. Okay, and this person is moving the sculpture. And I'm not good at drawing, so my sculpture is going to be just a box. Okay, what I know about the sculpture is that it has a mass of 180 kilograms and that it is made of metal. Okay, and this person is moving the sculpture on a metal platform. Okay, so the situation, the two surfaces that are in contact is metal on metal. Okay, so I'm going to look for the table, and I will look for this situation. What coefficients I have to use?
0.15 and 0.06.
That is correct. This is the situation that best fits the problem. Okay, metal on metal, 0.15 and 0.06. So I'm going to take the two coefficients up to the exercise. Okay, so with this I obtain mu s equals 0.15 and mu k equals 0.06. With this, now I can perform the diagram. I can do the diagram. Okay, because my sculpture is on a surface, is on a metal platform, which is a surface, I will have my normal force acting upwards. And since it has a mass, it will also has a weight acting downward. Because my sculpture is being moved, it means that it's moving in a certain direction, okay? So I will also include my friction that is going to be opposite to the object's motion, okay? And with this, now I'm going to be able to calculate the weight, the normal, and therefore the friction. So in the first step, I calculate the weight as mass times gravity. How much is this weight?
Se- 1765.
Point eight.
17,000.
Point?
1
8.
8.
These are kilograms meters over second squared, which is also the same as saying Newton. Okay? If you know the weight, you know the normal. This is going down. And the normal, it's going to have the opposite sign. It's going to be going up. Okay? Same value, but going up. Okay? So now, in the second step, what we do is we calculate our two frictions. We calculate static and kinetic friction. We substitute by the givens and we obtain the answer. How much do you get in the static?
264.87.
And in the other one?
105.95.
Okay, the two answers are given in Newton and that will be correct. Now, you in your notebook in this moment, you're gonna practice this topic. By doing the third exercise, okay? This is the exercise, the third exercise, okay? So you're going to work in this moment on your notebook. I'm gonna leave here also the table so you can use the coefficients. Did you get your answer? Freddy?
For static friction, I got 981, and for kinetic, 490.5.
And for kinetic, 490.5 Newton. That is correct. Those are the answers that I got. So as you can see, the application of the formula is very simple. All you have to analyze are the materials that the objects are made of. Okay? And in case that one exercise asks you to find, okay, because sometimes I will ask you to get the friction, but some other times I can ask you to get the coefficients, okay? Or I could ask you to find a normal. That depends. So you will have like to isolate the formulas. For example, if I ask you if the materials, okay, are not indicated, but they are giving you the friction, and they're asking you to find the coefficients, for example, the kinetic coefficient is going to be equal to, you just isolate the formula, to the friction kinetic divided by the normal, and in the case that it's asking you to find the static coefficient, it's going to be equal to the friction static over the normal. That will depend on the kind of exercise. But here is just like the introduction of the other topic that we'll see about Newtons, and we cannot get into that if you don't know what the friction is. Okay, so for Thursday we're gonna no for Wednesday we're gonna be doing a quiz for the second law, that is this one. Okay, mass times acceleration, and about calculating the friction, which is this topic that we saw today. Okay, so that will be that. These are the two topics that the quiz will be about on Wednesday, and you know it's gonna be 10 points. So remember to review the exercises. Use the calculator again just to check that you are getting the same answers as we did in class. And if you have any doubt on something, you can ask me. Okay? So I don't know if you have a doubt on today's exercises. Ready?
Miss, can you put the table of the
I
units?
will send it.
No, but it's for a question that, for if you put an example for on like rubber and wet concrete, what do we do with the unit of static motion?
Mm, okay, when you see like here is there's nothing, right? So that means that the friction, the static friction on wet concrete does not exist. Okay, so you don't get it, just get the kinetic one. Okay. Also happen with dry snow. Okay, the static does not work for us, so you just get the one that is on the table. So if there are no more doubts, I will stop recording.